practice page 7. So right here, we're trying to show that secant x minus tan x sine x is equal to 1 over secant x. So I'm going to work on the left-hand side. I'm going to pretend that I don't see the right-hand side right now. And I'm going to try to use my identities and simplify so that it looks like the right-hand side, so that it looks like 1 over secant x. So I like to work with sine and cosine. I'm going to do 1 over cos of x minus, we know that tangent is sine over cosine, and in the numerator we also have sine of x, right? Because it's tan times sine, put that over 1. So then we have 1 minus sine times sine is sine squared x over cos x, right? The denominators are the same. So on top we have 1 minus sine squared. Now when we see ones and squared terms, we want to think about our identities. I know that sine squared x plus cos squared x is equal to 1. So cos squared x is equal to 1 minus sine squared x, and sine squared x is equal to 1 minus cos squared x. That will come in handy. If we look right here in the numerator, we have 1 minus sine squared, and 1 minus sine squared is equal to cos squared x. So cos squared x over cos x. So in the numerator we have cos x times cos x, denominator cos x, and cos x cancels numerator and denominator. So we have cos of x. That's the left-hand side. And we want it to look like the right-hand side of the original problem. And the right-hand side said 1 over secant. And we know that cos is the same as 1 over secant of x. So we've proved that the left side equals the right side. Let's look at this next problem, number 2. I'm going to start with the right-hand side. I'm going to play around with sine and cosine. I am going to not look at the left side, but in the end, I want my result to look like the left side. So I'm going to cross this off so I don't get confused. Cosecant is the same as 1 over sine of x. Cotan is cos x over sine x. And then we can combine these fractions because both the denominators have sine x, and on top we have 1 plus cos x. And if we look at the original problem, it said 1 plus cos x over sine x, so we're done. Not too much work for that one. Let's head down to our next problem. Let's look at number 3. So for number 3, we're going to start with the left-hand side. We're going to try to work with the left-hand side and get it to be 1. So in the numerator over here, I have secant. I know that secant is, actually I'm going to first write it like this, secant x times 1 over cos x. I'm going to first work with this, okay? So secant x times 1 cos is the same as secant over cos. So secant I can rewrite as 1 over cos x, and we multiply that by 1 over cos x. So that's 1 over cos squared x. Now you play around with the tan x, cotan x. So I have minus tan x over 1 times 1 over cotan x. Now we can take this and we can rewrite this as negative tan x over 1 times tan x over 1. We can write this as negative tan squared x. Over here, we can write this as secant squared x minus tan squared x. We can replace secant squared x with what? Sine squared x plus cos squared x equals 1. If we divide all terms by cos squared x, we'll get tan squared x plus 1 is equal to secant squared x. So I can replace secant squared x with tan squared x plus 1. So over here, I'll write tan squared x plus 1 minus tan squared x. So tan squared x minus tan squared x is gone, and I have 1. And that's what was on the right-hand side, so we're done. Now let's try number 4. I'm going to erase some of this. So for number 4, we're going to play around with the left-hand side, and we're going to try to get it to equal sine squared x. So I'm first going to cross that off. Now this one's pretty messy right now. In the numerator, we have secant x sine x. So I'm going to write it like this. Secant x sine x divided by quantity of tan x plus cotan x. And we can play around with secant x and write this as 1 over cos x times sine x over 1. So we have sine x over cos x. And we know that's tan x divided by, over here we have tan x plus cotan. So we know tan is sine over cosine x plus cotan is cos over sine. Now to add, right, to combine these fractions, we need to have same denominator. So we'll multiply the left side by sine x and the right side by cos x. So we have sine squared x plus cos squared x over sine x cos x. And we know from the identities that sine squared plus cos squared is 1 over sine x cos x. So here we have divided by. And we can put tan x over 1. So we have tan x over 1 times sine x cos x over 1. Okay, let's rewrite tan with sine over cos. So we can rewrite tan as sine x over cos x. We can multiply that by sine x cos x over 1. Our coses cancel, so we have sine squared x. We have found what we had on the right-hand side. So check, we're done.